Code in C++. Write a lightweight bitstream class. Write bits, read bits, so you can serialize your RDS units efficiently. This is the secret sauce of bandwidth optimization. In a standard C++ struct, a bool takes 1 byte, 8 bits. In a bitstream, it takes 1 bit. An integer, 0-100, takes 4 bytes, 32 bits. In C++, in a bitstream, it takes 7 bits. For an RDS with 500 units moving 10 times a second, this compression reduces your bandwidth usage by 75%. The concept, the scratch pad. We don't write directly to memory, writer. We shift bits into a UNT64T scratch variable. When the scratch pad fills up past 8 bits, we flush a byte to the vector, reader. We read a byte into a UNT64T scratch pad. We peel off the requested bits, shift the scratch pad down, and repeat. The header, bitstream age. This class handles the messy bit shifting math for you. C++ include, vector, include, xtint, include, string, include C-string for memcopy, include, math, for floor seal, include, algorithm, for clamp, comma bit writer, comma class bit writer, public, std, vector, unt8t, buffer, private, unt64t scratch, int scratch bits, public, bit writer, size t reserve bytes equals 1024, scratch, 0, scratch bits, 0, buffer reserve bytes, 1, the core function, write n bits void write bits, unt32t data, int bits, mask data so we don't accidentally write garbage from higher bits, unt32t mask equals, 1, bits, 1, if, bits equals 32, mask equals 0xff, handle 32, bit shift edge case, data and equals mask, shift data into our scratch pad, scratch equals, unt64t, data, scratch bits plus equals bits, flush full bytes to the buffer while, scratch bits, equals 8, buffer pushback, unt8t, scratch and 0xff, scratch, equals 8, scratch bits equals 8, 2, helper, write a boolean, 1 bit, void write bool value, write bits, value 1, 0, 1, 3, helper, write a float efficiently. One of the most important functions for RDS networking val, the float min-max, the range of the world, e.g., 0 to 4096 map size, precision, how many bits to use, e.g., 16 bits equals 6.5 centimeters, accuracy on 4 kilometers map, void write float val, float min, float max, int bits, float normalized equals, val, min, max, min, float clamped equals std, clamp, normalized, 0.0f, 1.0f, unt32t max val equals, 1, bits, 1, unt32t integer val equals, unt32t, clamp max val, write bits, integer val, bits, call this at the end to flush any remaining bits, void flush bits, if, scratch bits, 0, buffer pushback, unt8t, scratch and 0xff, scratch equals 0, scratch bits equals 0, const unt8t get data, const, return buffer data, size t get bytes used, const, return buffer size, comma bit reader, comma class bit reader, const std, vector, unt8t, and buffer, unt64t scratch, int scratch bits, size t byte index, int total bits, public, bit reader, const std, vector, unt8t, and in buffer, in buffer, scratch, 0, scratch bits, 0, byte index, 0, total bits equals in buffer size, 8, 1, the core function, read n bits unt32t read bits, int bits, if, bits, 32, return 0, safety, if we don't have enough bits in scratch, pull from buffer while, scratch bits, if, byte index, buffer size, scratch equals, unt64t, buffer, byte index, scratch bits, byte index plus, scratch bits plus equals 8, else, reading past end of buffer, return 0 or throw error in game networking, usually just return 0 to prevent crash, scratch bits plus equals 8, fake it to avoid infinite loop, read the bits unt32t mask equals, 1, bits, 1, if, bits equals 32, mask equals 0xff, unt32t result equals, unt32t, scratch and mask, remove used bits, scratch, equals bits, scratch bits equals bits, return result, bool, return read bits, 1 equals 0, float read float min, float max, int bits, unt32t integer val equals read bits, unt32t max val equals, 1, bits, 1, float normalized equals, float, integer val comma float, max val, return min plus, normalized max, min, check if we have processed all bytes, bool can read, const, return byte index, buffer size, scratch bits, 0, usage example, serializing an RDS unit, this demonstrates exactly why we use this, a standard serialization of this unit would be 17 bytes, plus padding, with bitstream, we get it down to 5 bytes, C++ struct RTS unit, unt32t unit ID, max 1024 units, 10 bits unt8t type, max 16 unit types, 4 bits float x, z, map size 1000.0f, 12 bits each bool is attacking, 1 bit unt8t health, 0-100, 7 bits, void test serialization, RTS unit my unit equals, 500, 2, 120.5f, 400.1f, true, 85, writing, bit writer write bits, my unit ID, 10 bits, 0-1023, writer write bits, my unit type, 4 bits, 015, Compress position. Range 0 to 1000. 12 bits precision writer write float. My unit X. 0.0 F. 1000.0 F. 12. Writer write float. My unit Z. 0.0 F. 1000.0 F. 12. Writer write bool. My unit is attacking. 1 bit writer write bits. My unit health. 7. 7 bits. 0 127 covers 100. Writer flush bits. Important. Comma packet size. Total bits equals 10 plus 4 plus 12 plus 12 plus 1 plus 7 equals 46 bits. 46 bits 8 equals 5.75 bytes. This will create a vector of size 6. Comma reading bit reader reader. Writer buffer. RTS unit output. Output unit ID equals reader read bits. 10. Output type equals. UND8T. Reader read bits. 4. Output X equals reader read float. 0.0 F. 1000.0 F. 12. Output Z equals reader read float. 0.0 F. 1000.0 F. 12. Output is attacking equals reader read bool. Output health equals. UND8T. Reader read bits. 7. Critical RTS optimization tips. Quantize everything. Never send raw floats for positions. Write float is your best friend. 10 bits equals 1024 values. On a 1000 meter map, that's 1 meter precision. Bad. 12 bits equals 4096 values. On a 1000 meter map, that's 25 centimeters precision. Good enough for movement. 16 bits equals 65,536 values. Pinpoint accuracy. Still half the size of a float. Dull to compression. In your send message logic. From the first step, don't just send the unit's position. Store the last sent position. If abs, current x, last sent x, 0.1. Don't write the bits for x, write a single bit has moved. If 0, skip reading x and z bit budgeting. During development, define constants for these bit counts. C++ constant bits unit ID equals 10. Constant bits pos equals 12. Constant bits HP equals 7. This allows you to tune the global precision of your engine by changing one number.